So this is another area of the class that's pretty close to some of my research, and I'm going to take a moment to talk about two approaches to achieving privacy, statistical privacy in databases. And I'm doing this in part because I think if you go to a research university, you owe it to yourself to understand some of the research that's going on at that university. Otherwise, you're losing out on one of the biggest advantages that the research university has to offer. Normally, when I'm introducing this concept, we would spend a bunch of time defining privacy and inspecting various elements of what makes privacy different from security. But I'm going to skip ahead some because I want to demonstrate in particular the technical challenges posed by privacy in databases, in data storage. There is one thing that we do need to cover before we get to that, though, to give you a sense of what privacy means and how different it is from security. And that is the nothing to hide argument. Right? So the theory behind this argument is that surveillance only threatens privacy when people have done something wrong, and this surveillance is uncovering wrongdoing. And you may hear this phrased as, well, if you've got nothing to hide, then you have nothing to fear by revealing data about yourself. Sometimes there's a variant that you will hear essentially saying, well, what I'm doing isn't all that important anyway, so I don't mind giving access to it. These are both very damaging arguments from the perspective of understanding privacy and what it means. They're important misconceptions. They're very problematic ways of viewing privacy because privacy is ultimately a civil liberties issue. And it's the kind of thing that's very difficult to reason about if all you're doing is looking at how it affects one individual. You have to look at how it affects an entire society. So one quote that I like that really demonstrates this, at least the nature of this, is this from Julian Sanchez, where he says, focusing on what I have to hide is a weirdly selfish way to think about privacy. It's like saying, I'm white, why should I care about racism? And that is absolutely the best encapsulation of why the nothing to hide argument is problematic from a privacy standpoint. So bear in mind when we are talking about database privacy or privacy in large data sets, this is the kind of focus that we have. We're mostly interested in identifying societal level concerns and protecting people who are vulnerable simply because we ourselves may not be vulnerable. Does not mean that we should not care about this as a concern for the data set. All right, so privacy in large data sets. Businesses, governments, universities all have huge data sets that they think would be useful if released to the public for research and analysis. This is often stated in healthcare. You can think of this as an important concern in fighting COVID-19. The census, which is also going on this year, is another good example of how this is useful, how this sort of technique may be useful. And there are many, many, many other big data style applications for achieving privacy in an anonymized data release. The problem is anonymization is hard. It's very difficult to do correctly. There's three examples that I'll walk through here of how problematic anonymization can be. The first is when the Massachusetts governor was identifying a set of anonymized healthcare data set, or interested in releasing a set of anonymized healthcare data to the public so that they could perform healthcare research. Well, one of the first pieces of research to come out of that data release was from a Harvard researcher who linked that data to public voter registration lists and identified the Massachusetts governor's data and sent it back to him saying, well, how privacy protective do you think this is now? Another important example of anonymization and how difficult it is to get correct was the Netflix data release. So roughly 10 years ago, Netflix released a whole bunch of data to the public so that they could compete to improve the recommendation algorithm Netflix used for recommending movies or shows to viewers. And the idea was that if you could improve it by a certain percentage, you'd get $1 million prize or something like that. And one of the researchers took this data set and decided to try and re-identify it by linking it to the IMDb data set. Both of them at the time used a 5-star rating list, and many people, after they finished watching a movie on Netflix, they would rate it on Netflix and then immediately go and rate it on IMDb. And by using those common ratings, you could re-identify about 80% of the data for certain and certain percentages with high probability thereafter. A lot of people have been looking at that Netflix data release over the time to try and figure out just how much of that data could be re-identified based on linking it to some other database. And then the final data set that I want to talk about is the AOL search data that was released. Importantly, this is one that did not require linking to other data sets for individuals to be re-identified, because search data itself is often inherently identifiable. So for example, if you were searching for directions to get back to your house from some store that you went to, that's not going to be possible to anonymize, right? You can't remove the address of the personally identifiable information from that search data without literally removing that entire piece of data. So it's very difficult to anonymize data sets in general, and many, many particular examples show the challenge, at least demonstrate how problematic this sort of thing is for large data sets.